Okay guys, so this is part 2 of day 2's lesson, and this is where we're going to start using something called the unit circle. So the first thing we're going to do is, it's called a unit circle because we're looking at basically a circle on a coordinate plane with a radius of 1. But what we're going to do is we're going to fill in all of the different degree values that are marked by these lines on here. So the very first one we're going to mark is just our initial side, which is just 0 degrees. And then we're going to fill in all those major lines that we've already used. So the ones we've already talked about, we've got 90 degrees, 180 degrees, 270 degrees, and then all the way around a full circle we know is 360. So now we're going to fill in the lines that are halfway in between. So like this first one here, halfway between 0 and 90, you guys know is going to be a 45-degree angle. Halfway between 90 and 180, it's going to be 100. Hi guys, so this is part 2 of our lesson. We're going to start talking about the unit circle. So what the unit circle is, it's just a circle on a normal coordinate plane that has a radius of 1. But what we're going to look at on it are the different degree values, and then after that we're going to look at the different radian values. So the first thing we're going to do is we're going to look at the degree values on here, and I'm going to label those degrees that we've already used to kind of draw our angles. So the first one we looked at was 0 degrees, and then we knew where 90 degrees was. We knew a straight line was 180, and then 3/4 of the way around our circle we knew was 270. And then all the way around the circle at the same place as 0 is 360 degrees. And both of those angles are coterminal, which we learned about yesterday. Because they end in the same place. One's a full circle around and one's just the initial side, but remember, coterminal angles, you can add or subtract 360 as many times as you want. So the first lines that we're going to fill in are these lines that are in the middle of those border lines. Okay, it's like this first one right here. It's halfway between 0 and 90, so we know that that one is going to be 45 degrees. I've got halfway in between 90 and 180, and that one is 135 degrees. So if you look, the difference between 0 and 45 and 90 and 90 and 135, 135 and 180, all of them have a difference of 45. So I just need to keep adding 45 degrees to find my different angles. So this one right here would be 225. And then finally this last middle one is going to be 315. So now the next one we're going to look at is the line closest to 0. And that line right there is going to be 30 degrees. Okay, then the next line that we haven't filled in yet, that line is actually going to be 30 degrees away from 30, so that line is going to be at 60 degrees. And what we're going to do to find all the rest of these lines, if you look, I go from 0 to 30, I add 30. I add 30 again, I'm at 60, add 30, I'm at 90. So all I need to do is just keep adding 30 degrees. I'm going to skip those 45-degree lines. But if I go all around this circle and I continue to add 30, it'll give me all my missing values. So after 90, I'm going to be at 120 degrees. Then next, I'm going to add 30 to 120, and I'll be at 150. Adding 30 puts me at 180. Adding 30 again puts me at 210. The next one is going to be at 240, then 270. Next we've got 300, and then the next one, our last one on there right before 360, is going to be 330 degrees. So these are the degree values of the unit circle. Now we're going to be doing a lot with these this year, so it's going to be beneficial for you guys just to be familiar with where these are. But we're going to look at the unit circle with radian values. And this is going to be a little bit tougher because this has a lot to do with some fractions. But the first thing again we're going to do is we're going to fill in those values that we know. We know again that I start at 0, and I know a full circle around a unit circle in radians that we talked about earlier. All the way around a full circle is 2 pi. So if I had a radius of 1, that circumference would be 2 pi. So a full circle is 2 pi radians. So if a full circle is 2 pi radians, then half of a circle is just going to be pi radians. And then I can easily find halfway between 0 and pi. That's going to be pi over 2. And then in between 1 pi and 2 pi is 1.5 pi. But we're not going to write it as 1.5. You're more frequently going to see radian values written as improper fractions. So 1.5 is the same as 3 over 2. So we're going to write that as 3 pi over 2. And it's the same thing as 1.5 pi. You're just going to see it more commonly written that way. So again, we're going to do this just like we did with degrees. We're going to fill in these middle values first. So halfway between 0 and pi over 2 is 1/4 of a pi, which is pi over 4. And then just like I kept adding 45 degrees on degrees, I'm going to keep adding the equivalent radial value, which is pi over 4. So if I add 1 pi over 4, that would put me at 2 pi over 4, which reduces and is pi over 2, which I already have. But then I'm going to add 2 pi over 4 to another pi, and that puts me at 3 pi over 4. Adding another pi over 4 would put me where I already have figured out at pi. So 4 pi over 4 plus pi over 4 would be 5 pi over 4. 5 pi over 4 plus pi over 4 would be 6 pi over 4. But again, we know 6 pi over 4 reduces to what we already have, which is 3 pi over 2. And 6 pi over 4 plus another pi gives me 7 pi over 4. So I filled in all of those equivalent 45 degree, adding 45 degree lines with radian values. And if you guys notice, there's something in common with all of those. Alright, so now what we're going to do is we're going to look at the one closest to 0, which was 30 degrees, but as the example we did before this, we saw that 30 degrees is the same thing in radians as pi over 6. So instead of just converting all these different degree values to radians, we're going to do this a very similar way. What we did before, like with the pi over 4s, is we kept adding that same amount. So again, we're going to take pi over 6 to get this next line, and we're going to add pi over 6, just like we did with 60. We did 30 plus 30. So we're going to do pi over 6 plus pi over 6, and that gives me 2 pi over 6. But instead of writing 2 pi over 6, I want to reduce this. And you guys know that 2 pi over 6 is going to reduce to pi over 3. So 60 degrees is going to be the equivalent of pi over 3. Alright, so then my next line would have been 2 pi over 6 plus pi over 6. That would have been 3 pi over 6. But I already know that 3 pi over 6 is pi over 2 when I reduce, so I don't need to use 3 pi over 6. And then again, if you look, each of these lines from here on out, we're just going to add another pi over 6 every single time. So my next one, let's see here. Oh, well, let me erase it anymore. Alright, the random 3 pi over 6 is going to stay. So what we're going to do now is this next line, I went from 3 pi over 6, that's going to turn to 4 pi over 6. But 4 pi over 6 reduces, and I get 2 pi over 3. So then I'm going to move on. 4 pi over 6, my next one would be 5 pi over 6. Then my next one, it would be 6 pi over 6, which is already pi. After 6 pi over 6, I get 7 pi over 6. Then my next line would be 8 pi over 6, which we already know reduces. 8 pi over 6 is going to reduce to 4 pi over 3. So then after 8 pi over 6, my next line would be 9 pi over 6, which I already have. It's just reduced to 3 pi over 2. Then after 9 pi over 6, I'm going to have 10 pi over 6, but 10 pi over 6 again can reduce, and that's going to reduce to 5 pi over 3. And then finally my last line after 10 pi over 6 is going to be 11 pi over 6. Now one thing, you guys might notice a few things about these. All of the lines that are closest, the blue ones, are all the closest to the x-axis, and all of the blue radian values are pi over 6 values. And then all the red ones are closer to the vertical line, or farther away from the x-axis. And all the ones that are farther away are pi over 3 values. And we're going to talk a little bit more about why that is on Friday when we talk about reference angles.